Hello Math 2 students. The purpose of this video is to help you learn how to solve right triangles. You'll see right triangles that have some given information and some missing information. It's your job to fill in all of the missing information. You can use Pythagorean theorems, including Pythagorean triples. You can use special right triangles, 30, 60, 90, and 45, 45, 90. Or you can use the sine, cosine, and tangent, or inverse sine, cosine, and tangent. You'll notice that sometimes I'll do the problem one way and you might be thinking that it would be easier to do it a different way. That's possible. With so many tools, there are many ways that you can solve some of these problems. Make sure you highlight your notes and do these examples with me. Example 1, solve the right triangle. Round decimal answers to the nearest tenth. So on this problem, the first side I'm going to try to find is side YZ. We're looking for a side. We know two sides, so we will use the Pythagorean theorem. But on this problem, we won't use c squared equals a squared plus b squared because on this problem, we have a 5, 12, 13 Pythagorean triple. So I know that side YZ is 12. Now I'm going to find the measure of angle X. And we know three sides, so we know at least two sides that we need. And we're going to use trigonometry, SOHCAHTOA. And on this problem, because we have the adjacent and the hypotenuse, I'm going to use the cosine. X is my reference angle. My hypotenuse is 13, my adjacent is 5, and the 12 is my opposite side. Since they gave me the adjacent and the hypotenuse, I'm going to use cosine on this problem. So I have cosine of x equals the adjacent over the hypotenuse, 5 over 13. Then this is going to become x equals the inverse cosine of 5/13. Angle X is equal to 67.4 degrees when I round off to the nearest tenth. And finally, to find the measure of angle Z, I need to use the triangle sum theorem. So I have 180 degrees minus the right angle, which leaves me with 90 degrees. And 90 degrees minus 67.4 will give me angle Z, and angle Z is 22.6 degrees. Example 2, solve the right triangle. Round decimal answers to the nearest tenth. On this problem, I'm going to start out by finding side KO to begin the problem. I'm looking for a side, and I know that I have a 60-degree angle. So I'm going to use a 30, 60, 90 special right triangle. Remember, a 30, 60, 90 special right triangle is half of an equilateral triangle where the height involves the square root of 3. But on this problem, because I know the long leg and I'm looking for the short leg, I will use this formula. The long leg equals the short leg times root 3. And on this problem, I don't know what the short leg is, but I know that the long leg is 18. So my equation will look like this. 18 equals the short leg times root 3. In order to solve for the short leg, I need to divide both sides by the square root of 3. And so my short leg is 18 over root 3. But I can't leave my answer that way. I need to rationalize the denominator. So I'll multiply the top and the bottom by the square root of 3. And that will make my short leg equal to 18 root 3 over 3. And the last step is 3 goes into itself once, and 3 goes into 18 6 times. So the short leg is equal to 6 root 3. To find Kn, the hypotenuse, which is a side, I'm going to use my 30, 60, 90 special right triangle again, but this time because I'm looking for the hypotenuse, I will use that formula there. Now I'm using the formula the hypotenuse is equal to the shorter leg times 2. And in my problem, I just found out that the shorter leg is 6 root 3. So my hypotenuse will be 6 root 3 times 2. So my hypotenuse is 12 root 3. And finally, I'll use the triangle sum theorem to find the measure of angle N. So I have 180 degrees minus the right angle, which is 90 degrees, minus the 60 degree angle, which is 30 degrees. And that's why I was using a 30, 60, 90 special right triangle. So angle N is 30 degrees. Example 3, solve the right triangle. Round decimal answers to the nearest tenth. Now I know in the last problem I didn't change my simplified square roots into decimals rounded to the nearest tenth, but I think everyone knows how to do that on their calculator. I think it's more important that you remember how to simplify the square roots when that comes up, and if the problem allows you to put them into decimal form, then you can just use your calculator to do that. The first thing I'm going to try to find on this problem is the hypotenuse, side AC. I'm looking for a side AC, which is the hypotenuse, and I know two sides, so I'm going to use the Pythagorean theorem. This time I know that it's not a Pythagorean triple because one of its sides is 2 root 5. So I will use the formula c squared equals a squared plus b squared. So I have c squared equals a squared plus b squared. So it's going to look like this. And my hypotenuse is unknown, so I'm going to put an AC there. And my two legs are 6 and 2 root 5. So now I'm going to have AC squared equals 36 plus 2 squared is 4, and square root of 5 squared is 5. So this is 4 times 5, which is 20. So I have AC squared equals 56. Now I take the square root of both sides, and AC equals the square root of 56. Now to simplify the square root of 56, I have to look for the biggest perfect square factor that can go into 56, and that biggest perfect square factor is 4. So this becomes the square root of 4 times the square root of 14, which is 2 root 14, and that is the length of my hypotenuse AC. Now I'm going to find the measure of angle A. To find angle A, when I know the sides, I'm going to use trigonometry, SOHCAHTOA, and on this problem, I'm going to use tangent because I know the opposite and adjacent. So the tangent of A equals the opposite over the adjacent. So we have A is our reference angle, this is our hypotenuse, this is our adjacent, and this is our opposite. So opposite over adjacent is 2 root 5 over 6. And when I solve that, it's going to be A equals the inverse tangent of 2 root 5 over 6. And when I put that into my calculator, I find out that the measure of angle A is 36.7 degrees when you round off to the nearest tenth. Finally, I'm going to find the measure of angle C by using the triangle sum theorem. So I have 180 degrees minus my right angle, that leaves me with 90, minus 36.7 degrees, and that makes angle C 53.3 degrees. After watching this video, you should be able to find missing sides of triangles by using either Pythagorean theorem, special right triangles, or sine, cosine, and tangent. You should also be able to find missing angles of triangles by using the inverse sine, cosine, and tangent, or the triangle sum theorem. Thanks for watching.